All right. Um, all right. All right. This is phenomenal. Phenomenal. Um, so we took a look at the lambda loss function, and we said it is not what we want. Let's go take our model further. And if somebody studied it before, he comes and says, "Oh, this is what we actually done before." I'm not gonna read other people's work to see my model doesn't work or it's been studied before. Um, so yeah, I have some more papers actually. Let's let's not read them. Okay, let me add them to my list, and then I remembered Eson sent me two papers on reinforcement learning and ranking. And they are different. Good to know about the literature that are in my research focus, but not going to the detail. Aggregate e-commerce search results from heterogeneous sources via hierarchical. Oh, reinforcement. Okay, well, let's skip this one. And reinforcement. Okay, this one we studied before. Cooperative. This one we have it. Anyways, we download. As I said, it already existed there. As I said, it already existed. By the way, why is the AC on? Why is the AC on? Mhm. So, so, let's go. Okay, what is our methodology? We said let's keep the model simple. So each position has a boost effect, which is b of pi I, and we have also a relevancy, which is ri, right? And we say if user goes up to position pi I, it means that either ri is 1, we can say ri times b pi I greater than rj times b pi j for any j greater than I. Sorry, for any j which pi j is less than pi I. But as we talked also last time, this mechanism always kind of has a blind spot. Well, it doesn't have blind spot, to be honest. Always is questioning the products at the top rank, not the lower ones. Yeah, like it's kind of cynical to the ones that are at the top of the ranking. Well, okay, based on this click behavior, we can say that. However, if the product number 1 is getting clicked, does it mean that product number 1 is really good? What about that? We don't learn anything from this. From this model, this model is oblivious to product number 1 being clicked. Well, when product number 1 is getting clicked, we say that okay, Ri is greater than this number, like R1. Sorry. What is the I that is located at position 1? Let's say I is pi minus 1 of 1, right? Ri b pi I well, this one gives us Ri1. Well, it is good, which brings score of number item at position 1 high, right? Let's go through it again. Here we said there is an aggregate, each user gives us an relevancy score, and well, for the last part we just mentioned, I really like to know how Ehsan thinks. Or we can say also For example, if an item is clicked, pi I Ri is greater than a threshold t. Okay, not t, because I want to use t for time. Eta, and then Ri will be greater than eta over b pi I. Actually, I think that's enough. Okay, now let's go how we behave actually. You are a user on an e-commerce platform, you go through the list. I think this model is simple. This model is simple. Which is good, but lacks the consideration set. Notion. If you want to make it more complete, you may say, okay, I may go up to position J or I on the list, but it doesn't mean that I choose number I. The way we are interpreting a click is that the user checked items before item I and said they are not good, item I is good. A more realistic model says I come to number I, it cost me, and then I make a consideration set and choose one of them. I feel both models are good. They have their own values. The simpler model is simpler, but it lacks this consideration set behavior. So I feel it is good. This model up to here is good, and we wanna yeah, this is good. By the way, what is the firm, the platform's utility? I think thinking further about this is not good because I want to discuss it and then talk about it. And so what is the next model? We can write it down in the overleaf, by the way. And the next model is the mechanism design model, which we already discussed. We have queries and we have intents. Queries can be less specific, but intents are the most specific ones. And we have a mechanism. Once we have a query here, and these two are two intents, once we have a query here, we have a rule on how to mix the result of these two intent for this query. And they have the prior theta vi. So once this query is searched, what is the probability? It is v1. We say, let's assume independence and everything, and we say it will be theta v1 over theta v1 plus theta v2, right? This is the odds. And let's assume we put 4 objects from type 1 4 objects from 2, and DCG will be sigma Ri, Ri, okay, 2, what was the formula? 2 to the Ri to the relativity minus 1. Well, it is another form of relevance, right? Over log 2i plus 1. If relevance is 0, it's 1. Okay, it's just, okay, I can use 2. Alright, because I wanted to say relevance of an object that matches the intent is 1, which ends up the numerator to be 1 here, and an item that does not match the intent, its relevance will be 0, which will be 0 on the numerator. Alright, so here I can say DCG will be sigma Ri over log 2 1 plus pi of I, right? And then expected DCG will be, well, we are not having any platform yet. Expected DCG will be theta v1 over theta v1 plus theta v2 sigma I equal 1 to 4 1 over log 2 1 plus I plus theta v2 theta v1 plus theta v2 I equal 1 to 4 I equal, over log 2 5 plus I, right? Well, that makes sense. Now let's assume we can play with the 4. If the 4 is set, right? If the 4 items top, 4 items low is set, we will always end up putting the good one, the higher probability ones on the top of the list, the lower probability ones at the low of the list, right? And That's why DCG is actually stupid, because if I could choose how many put from item, like if I can say I want to put X number from V1 and like I don't know, N minus X number, which N is fixed, length of the ranking, L. L minus X number to the V2, I will get expected DCG will be theta V1 over theta V1 plus theta V2. They are a bigger set of mechanisms, right? Sigma I1 to X 1 over log 2 1 plus I plus theta V2 theta V1 plus theta V2 I equals X plus 1 to L 1 over log 2 1 plus I, right? And what is the best number of X? I say X optimum is L. Why? It just expected DCG of X is increasing. Which sucks actually. It means flooding is the good way to go. Expected DCG of it says flooding is the way to go. What will it be? It will be theta V1 over theta V1 plus theta V2 1 over log 2 X plus 2 plus 1, the other one starts from X plus 2 minus theta V2 over theta V1 theta V2 1 over log 2 X plus 2, which is positive. So this says it is always positive. So actually we have to flood if you want to maximize DCG. Well, this is something we have to discuss actually. Got a couple number ones. Actually, okay, we said top of the list, bottom of the list, but any position that you put any position that you put an item from the less probable category, you can switch it with a more probable category and gain DCG. So it seems DCG cannot be our metric. And I assumed RI is 1 for everything that is in the first category, and zero for everything that is not in the category. That can be also changed, but I don't think it makes a big difference. because let's assume for intent v1 we have a relevance of items I in v1, items that belong to category v1, we have an Ri for them, Rv1 of I for them. And R of I, item I, for consumer equals 0 if consumer equals not equals v1, if consumer n, right, n type, consumer's type is v equals v, if v is not v1, if v is v1, it is Rv1 of I. Then let's say we have v1 and v2, two lists, and I want to say theta v1 is greater than theta v2. It should be flooded by v1, assume at position j, position pi j, we have an item j which is in v2. If I switch it with an item from v1, what we have is expected DCG, delta expectation in DCG will be, everything else stays the same. Either it was theta v1, it was from item 1, theta v1 plus theta v2, and we are gonna say that's why we have to make a difference. Maybe that's why we have to make a difference between platform's utility and consumer's utility. Okay, expected DCG difference will be theta v1 over theta v1 plus theta v2, 2 days for either it is item from v1 and we will have Rv1 of the item at position j, right? Log 2 1 plus pi j, or it is not from v1 and it was actually from v2, and we will receive minus we lose actually. RV2 of item J over log2. Okay, one thing that can help here is this relevance terms. If this relevance terms, theta v1 rv1 of I greater than theta v2 rv2 of j, then all right, that was a good change. But if it is less than, we better put this. So that first course assumption that everything belongs to item 1 gives you a 1 relevance, and everything that doesn't belong give you a 0 relevance. That one said, okay, flawed. But this one that says, okay, even in V1 we have relevance score, for that intent, may change the game. And I think the good thing is that we can do for each position, we can do this. And how can it change the prior? I guess it suggests that for any position, you need to maximize theta vj rvj of the item. In J, in VJ. And everything that and if it is your mechanism and the consumers no theta v's, one other question we also have is how to find the categories, how many types, based on user behavior, how to find categories, because we want to study cases that the list is kind of mix of products with different types. Theta v1, theta v2. And I feel the good thing about this algorithm is actually you don't need to do the computations every time. You already know from your previous branch that which one is at the top, which one is at the low. You already did some of the comparisons. Like if I made the, okay, I have the list for here. It assumes I have the list for here. All right, I have a list for the end nodes with their relevance because they are homogeneous products. Homogeneous. So it's a backward method actually. And I already know that which one is better. But how will we change the theta? I see. How does this mechanism though changes theta? I want to say we assumed that we know thetas and we have a prior, but now that we implemented it, we need to question our assumptions. Make assumption, go forward, did your job, now question our assumption. We assumed we know thetas. Now it's time to question this assumption. Right? We came up with a list for any query for the graph, and now this is a forward method. Okay. Now, question. What is our question? Our question is, based on user's behavior, how can we find the prior? User how can find the prior, right? Wait a second, my meeting with Munzer is Falter meeting. Is at 1. Okay, let's go, dude. This mechanism leads to clicking for a bunch of... Okay, that's actually very interesting. Okay, it got interesting. Let's go